Hello and welcome back to day 2. So today we're probably going to go a little bit faster than yesterday, right? We started understanding the mechanics of how we're going to do TDD for this stuff. So let's get started. Let's take a look at our problem. So day 2, red-nosed reports. Fortunately, the first location historians want to search isn't a long walk. While the plant appears to contain no sign of the historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. Nice. They're quick to add that since you're already here, they'd really appreciate your help analyzing some unusual data. Your turn to check if the historians are waiting for you, but they seem to have already divided into groups and are currently searching every corner of the facility. You offer to help. Unusual data, your puzzle input, consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces. 6 reports of 5 levels. Engineers are trying to figure out which reports are safe. The red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both of the following are true. Levels are either all increasing or all decreasing. Any 2 adjacent levels differ by at least 1 and at most 3. Okay, so given these numbers, we have safe, unsafe, 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 safe. Unsafe because 2 to 7 is too big of a gap. Unsafe because 6 to 2 is too big of a gap. Unsafe because we change directions going from increasing to decreasing. Unsafe because 4 and 4 are neither an increase nor a decrease. Okay, so in this example, 2 reports are safe. Analyze the data, how many reports are safe? So we know that we got 502 because I did this problem already. So I've put in here 2 and 502. First thing we'll do is we'll go ahead and skip this. Not right now. So what we know we have is we have, here's our data, right? So we have reports. Each report is a list of levels, right? So each line is a report. Each report is a list of levels. Each report is safe if gaps are 1 to 3 always in the same direction, up or down. Okay. Count the safe reports, safe levels. That's what we need to do. Okay. So each line is a report. Each report is a list of levels. This is pretty simple. I don't think we need to put that in a separate class. Let's go ahead and do that here. So for each var line in file, read all lines of the file name, we're going to make reports. For each line, right, we're going to make reports. Var reports. This is each report is an array of ints, right? And we need multiples of those. Okay, so whoop. New keyboard, still trying to get used to it. So for each report, we're going to say, we can take a line and we can split it on spaces, right? Because if we look at the data, this is all split by spaces. And then we're going to convert each one of those things with an int parse. And then we're going to turn it into an array. So thank you, Link. That will give us all that stuff as an array of ints. We'll now have a list of int array of reports. And then we're going to say for each var report in reports, this is where the interesting logic is, which is it safe, right? So let's say we want to say if if level analyzer is safe for that report, and result plus plus, right? And then that's our result. So what we need here is we need a level analyzer. And this is going to be an is safe, and this is going to take levels. Okay. So for right now, we can do a throw new not implemented. Okay, and now these tests are going to fail because we have not implemented, not implemented. That's good. But I really want to make this thing come into being in a way that is more interesting to me than just 2 and 502, right? I want to be a little bit more methodical about that. So let's make some level analyzer tests. And we're going to use the data that we already understand, right? So we're going to say, we're going to do theory here and public, so you can verify safety. And we're going to get levels. And we're going to get something that says this is safe. So that's what we really want to know. So given this, we can say, for example, inline data. We're going to have to do it like this. We know that we have 6 pieces of data here, right? Let's grab this. Let's do this. Whoops, we needed another one of those, didn't we? Okay, try again. Let's grab this. Let's insert these over here with a multi-line cursor. Add some commas so that this is like, you know, real data. Except that's not how I'm supposed to do that. That's okay. Grab that, throw it there. That looks better. Okay, what are you upset about? Inline data is not valid on, oh yes, I need the word void. All right, so now we have levels and we have safe. So one thing we knew about this is that 1 and 6, or 0 and 5 really, are safe, and the other ones are not safe. So these are all not safe. Don't know why you had an extra space in there. And those are safe. Okay, so we should be able to say assert equal is safe, level analyzer is safe of our levels. So we can do these one at a time. Okay, so let's do these one at a time. Let's go ahead and skip this for now. Skip, go away. And we can start by just returning true, because that's all the test has told us we need to do so far, right? Let's ignore our foreknowledge of this. So right now, that one passes. Okay, well then let's go to the next one. Is that one going to pass? That one's not going to pass because we expected false and it just gave us true back. Okay, so we now understand, I think, how to compute the safety of a level, right? We need to know, is it going up or down? Is every step safe? The first thing we need to answer is going up. So how do we know if it's going up? We would say levels sub 1 is greater than levels sub 0, right? So if we go 1, 2, 3, 4, 5, that's going up. And every step is safe means between 1 and 3 gap. Okay, so then what we want to do is we want to go through the levels. So we'll do index is 1. Index is less than levels length. Level plus index. We're going to say the distance is levels of index minus levels of index minus 1. Okay? Also, this distance is going to be positive if we're going up and negative if we're going down. So we're going to use going up to invert this. We're not going up. We're going to invert the distance. That way, the ones that are going down will look like they're going up, and we can just look for a gap between 1 and 3. Okay, so we will now say if the distance is greater than or equal to 1 and the distance is less than or equal to 3, then we just keep on going. Otherwise, we say we found a gap that was too big and you're not safe anymore. That's it. That's the whole algorithm. So now if we run this on our second piece of data, now we can see that it is computing the correct number. Let's go ahead and put the rest of our data back in here because we're pretty sure that it's going to work. And so there we go. We've got this now level analyzer here. Now this theory that I was skipping before that was giving us 2 and 502, let's try 2 and let's make sure we get 2. Okay, that's good. We got a passing test. And we'll just fake it. We'll say 503 just to watch it fail. Right, but it really did give us 502. So we are now confident that this is actually doing exactly what we want against real live sets of data. And we use the small set of data here as our analysis as to whether or not everything is working as we expect. Okay, we're halfway done, right? All right, so what's the next part? Next part is, the engineers are surprised by the lower number of safety reports till they realize they forgot to tell you about the problem dampener. Reactor-mounted module lets the reactor tolerate a single bad level in what would otherwise be a safe report. Like the bad level never happened. Now the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. So now, given that rule with our set of data before, we've got this notion of, are you allowed to skip a level? Makes things safe and not safe. So 0, 3, 4, 5, those are safe. 1 and 2 are unsafe. So let's go ahead and basically just copy this test. Is safe with skip. Okay, we don't have that yet. So let's go write that. Public bool static bool is safe with skip. And this is going to be our levels. And here we will throw not implemented. And once again, verify safety with skip. Once again, we're going to take our one piece of data. All right, and we got our method not implemented. Okay, great. To make this data pass, so first of all, we have to fix the rest of this data. These are now true. That's the difference between this and this, because the skips let us do this, right? True, false, false, true, true, true. True, false, false, true, true, true. Okay, good. So if we go ahead and return true, right? That's going to make our first piece of data pass. Good. Okay, second piece of data. Now going to be our failure point. And that's going to be false. Interestingly, I can just do this. Okay, that's the smallest step I could take to make this test pass. So far, so good. Now we expect this one to pass because this one is also false up here, right? So that one will pass. We don't really have to get into our actual implementation until down here on step 4, where we now have something different, where is safe with skip is different than is safe. Well, first thing we can obviously say is if it's safe, then you don't even need a skip, right? But now what are we going to do? Well, the instructions basically say we're going to need to remove one piece of data, one level, and see if removing one of those levels will make it safe. So basically, we're going to have to walk through the entire set of levels, removing one at a time, and see if that removal makes it safe. So remember yesterday we talked about O of n squared and how our 1,000 points of data times 1,000 points of data is 1,000,000 calculations. Well, if we're going to run another loop over the data again, how big is the real data? The real data today is a lot less big than the real data yesterday. We still have 1,000 data points, but most of them are, less than 10 items apiece. So now instead of 1,000,000 iterations, we've got 1,000 times 10 is 10,000. We already know that we can do that. So we'll go ahead and we'll do the brute force. So the easiest way to do this then is we're going to say, we're going to start with 0. Index is less than levels, length, right? And then we're going to say if is safe of something, then we're going to return true. Well, so what is this something? Well, this something is we have to construct an array without whatever index is currently pointing at. So The way we can do this is with the array combinations. So the first thing we'll do is we'll say levels from 0 to index. So that's everything to the left of index. And then we'll combine that with levels index plus 1 to the end. And one more square bracket there. So what this is going to do is this is going to create an array skipping over whatever index is, right? This is sort of standard index range things. It looks a little weird, I understand, if you've never done this before. This is a relatively new feature in C#, but what we should be able to do is run over the entire length, plucking each item out and saying, hey, if we remove this item, what happens? Okay, so now we come back down here. Is this item going to pass now? Okay, well, good. That item passes now. So what about these two? These two also pass now. So we're in a pretty good state, right? I think if we take our skip away, and let's make this 1544 instead of 544, just to make sure that we're seeing the right thing. And oh yeah, by the way, we forgot to write the code. So we basically need this again, except the difference is we want is safe with skip. Okay, so that worked. We've got, you know, we'll put some ones in here just so we can see the failures. 4 and 544, we got the answer. We got all the right answers we wanted. So this is the algorithm that we ended up with, which is first taking a look at whether or not one set of levels is safe. Another version that says if the whole thing is safe, then we're good. Otherwise, we start plucking a level out one at a time to see what happens. And if any of those are safe, then we're good to go. Otherwise, we're done. So I think actually we're pretty happy with where this landed. Coincidentally, I don't see a whole lot of refactoring that needs to take place here. We really have two loops, so we're still in O of n squared again, right? Because this is a loop and this is a loop. They're not sitting together anymore, but we do have to remember that every time we're running this loop, we're running the loop here again and is safe, right? So it is an O of n squared. I was talking to somebody earlier today about, you know, is this really O of m times n? And the answer is yes, but that's not the way it's represented. O of n squared is basically telling you you've got a loop inside of a loop, and you're looping over the data. The actual values are important, right? 1,000 times 1,000 for a million iterations is different than 1,000 times 10, you know, or 10,000 iterations. In our case, both were okay. So the brute force method works. There may be a better way to do this that is more optimal, but for today, we don't actually need that. So I think that's going to be the end of day 2 for us today. And I want to thank you for stopping by, and hopefully we'll see you next time.